Hi, everyone. Good morning. Thank you so much for starting your day with us. I'm very excited to be here with you all. How's everybody doing? Awesome. Do you all have your coffee this morning? Yes. So let's say you're walking into a coffee shop this morning, and you're ready to order your favorite drink. But the environment seems unusually loud. There is this noise of the blender that's running, people are talking, there is a loud background noise going on, and you're trying to place an order. The barista is not able to hear you. You're struggling yourself to make your request understood. You're finding yourself raising your voice, you're repeating yourself, and you're feeling very frustrated. So now consider that experience in the context of someone who communicates primarily using sign language. For them, it's not limited to noisy environments. It's a constant challenge when they're surrounded by people who do not understand sign language. So let's look at another example. You're in an important virtual meeting at work. You're excited, ready to contribute, collaborate. But just as you're getting started, your internet connection becomes unstable. The video freezes, and you're not able to see anybody's expressions or reaction. You're missing out on the facial cues, gestures, which are really critical in truly engaging in a conversation and understanding the discussion. Facial expressions, body language, lip reading play a critical role in truly understanding and making the discussions productive. In a world where these visual elements are limiting, the conversation just feels incomplete. So that is how it is for deaf and hard of hearing users who are trying to use technology or product services without adequate accessibility built in. So in this session, we're going to be talking about how to build a multimodal American Sign Language avatars with bidirectional translation capabilities. My name is Alak Ishwaradas. I'm a Principal Solutions Architect here at AWS.
My name is Suresh Pupandi. I'm a Principal Solutions Architect with AWS.
And hey everybody, I'm Rob Koch. I work at Slalom as a Principal Data Engineer. So great to be here. Thank you.
Awesome. All right. So how many of you have seen or attended our session last year? Awesome. I see some hands up. Thank you so much. So for those of you who have not, let me do a quick recap. So we introduced a solution called GenASL, which is a generative AI-powered American Sign Language avatars. So for those of you, who have not seen those sessions, we really dived into an architecture and did an initial implementation. But I'm very excited to share that this year, we've expanded the capabilities to generate human-like avatars and also included the bidirectional translation with the recent advancements in the multimodal AI space. So I'll get us started with sign languages and walk us through the bidirectional solution, and Rob will take us through the demo, and Suresh will cover the architecture behind the solution. So accessibility means that everybody who's using a product or a service receives the same level of benefit, irrespective of the condition that they may have or the disability that they may have. Assistive technology is a set of tools used by people with disability to accomplish certain tasks. The World Health Organization has published some alarming facts and statistics. There are 466 million people worldwide with hearing loss, and that includes 34 million children. And it's also estimated that by 2050, more than 3.5 billion people will need at least one assistive product. So sign languages are the deaf and hard of hearing users' primary language. It's a mainstream language, is their first language. Hand gestures, body movements, facial expressions are all used when communicating in sign language. So with that, Rob, how would you describe what is American Sign Language?
Yeah, sure. So ASL, or American Sign Language, is one form of communication here in the United States, in North America. So we use sign language, ASL here. There's a myth out there that sign languages all over the world are the same, and in fact they are not. They are completely different, and they use different words. The finger spelling methods may be different across the world. So here in America, we will be focused primarily on American Sign Language for the purpose of this talk. The reason why we're here with sign languages, because maybe there's subtitles, but they might not be good enough. Like you see here, for example, we've got this subtitles here on the screen next to me. This, what you might think, provides full equal access, but there are some drawbacks in relation to that. The language has nuances that might not be captured in subtitles or captions. They don't necessarily capture everything as far as regards to emotions, or if somebody's being sarcastic or joking, we may not be able to get that conveyed through the subtitles or the captions. So they're reading it and they're trying to figure out maybe what it means, and it's not all there. When people are giving a talk, and then after you may have a question, in those type of situations, I don't have a way to ask a question. So with sign language, it can help with that. Another reason that we would benefit from using sign language is feedback, like, hey, I need help with something, or can you provide feedback, and you're trying to interact with a person, going back and forth in communication with the speaker. So subtitles can be limited, like here, using American Sign Language. We have a form of a linguistic representation called ASL gloss, and that translates ASL to English text or English text to ASL, and that is kind of the intermediate stage that we call ASL gloss. So this example, hello, how are you? You can see the gloss on the right. It says hello, how, 1x, that's me, and the X means index finger. The 2P here is representing the second person that I'm pointing to. So if you see the next line here, 1X, 1P, so the 1P represents me. 2P is the other person. Third person might be, all of you or them. And so this is just showing an example of the linguistic representation. Hello, how are you? Then it says, I'm fine, thank you, how are you? And then here, of course, understand this is pretty basic just to show you the concepts here, but welcome to reInvent in this third example. You'll notice there's some filler words that are missing in the gloss representation, like to or am. In ASL, we don't use those particular words. They waste time, right? So we don't need to include them there. So this here, the FS in the last line on the right, that's representing finger spelling, reInvent, because we don't have a sign for that.
Perfect.
Did I explain it well enough, Alec?
Awesome. Thank you, Rob. Appreciate that. All right. So we talked about sign languages and American Sign Languages, right? And Rob explained the challenges on relying on simply just captions, and why, and also there is a global shortage of sign language interpreters. So a sign language avatar is an AI-powered digital agent that can engage in conversation, answer questions, all in sign language. So to address the two key challenges that we talked about earlier, like we really need sign language interpretation. Captions are not sufficient. And we also have a global shortage of interpreters. So we are introducing a sign language avatars. So there are two forms of use cases that you can think of for these sign language avatars: a narrative avatar and a conversational avatar. So a narrative avatar is a digital human that can translate an audio content into a sign language video in real time. And we also have conversational avatars, which are enabling the deaf and hard of hearing users to have a natural conversation with an avatar, and the avatar can respond back in sign language. The other scenario where the conversational avatar can help is to facilitate a conversation between the deaf and hard of hearing users and the hearing users, acting as an interpreter. So let's dive in. A narrative avatar technology will enable the deaf and hard of hearing users to access the multimedia content more effectively. So when a user is enabling an ASL feature, a customizable human-like avatar appears on the screen, And as the audio or the video content is playing, the avatar seamlessly begins a live translation and converting the audio into a video of the sign language, and therefore providing a visual interpretation of the content. So let's dive into a conversational avatar. And like I mentioned, there are two separate scenarios in here. First, where the deaf and hard of hearing users interacting with the avatar. The second one is where the deaf and hard of hearing user is interacting with a hearing person, where the avatar helps to be an interpreter. Am I losing the mic? Okay, so sorry about that. So in the first scenario, where the conversational avatar is facilitating the conversation between the deaf and hard of hearing users and the avatar. So let's look at the example where the deaf user is invoking Alexa and in sign language asking for what the weather is. And if Alexa in the display pops an avatar and the avatar is responding back in sign language. So that's a use case that you can think of for this scenario. Now, looking at the other scenario, you can take of an example where you're in a virtual meeting where we have both deaf and hard of hearing users and hearing users. So we are relying on the human interpreters. And we did talk about the shortage of the human interpreters. So in scenarios where there is a shortage, by simply enabling a feature in a video conferencing tool, we can have a conversational avatar join the meeting and start providing the translation back and forth, providing a seamless bidirectional conversational capability. So the avatar will translate the sign language into spoken English for the hearing people to understand, and the avatar can also convert the spoken responses back into sign language for the deaf and hard of hearing to understand. So therefore, it provides a seamless conversation between the two communication modalities. So I really want to call out that here, because there are two separate communication modalities. One is an English audio, and the other being an American Sign Language video. So having talked about the two avatar use cases, we can enhance the user experience to be optimal by providing customizations to the avatar and also providing an inclusive communication, supporting both the deaf and hard of hearing users and the hearing users. And through the adaptive feedback, the avatar can adapt to the user feedback to provide better clarity. And lastly, it can work in versatile environments, whether it is a virtual assistant or in team environments. So the other fun thing you can do is personalize your avatar, right? Like whether it's your favorite cartoon character or an animation, you can simply just choose and customize your avatar. So the two use cases of the sign language avatars that I talked about can expand accessibility across many industry sectors, starting from healthcare and life sciences, industrial and manufacturing, financial services, we have retail, media and entertainment, and education. So let's look at healthcare and life sciences, where you have a patient-doctor conversation that involves sensitive medical information, where the patient may not prefer having a human interpreter to do that conversation. So another example you can think of is in the financial services segment, where, again, there is some confidential, sensitive information relating to finances and personal loan situation. And again, you may not prefer having a human interpreter in those scenarios as well. And then in media and entertainment that we talked about with the narrative avatar, we can provide the multimedia accessibility and also in education. So having talked about the different industry sectors, I'm going to pick a few sign language use cases here. So we talked about the workplace meeting where an avatar can simply join a video conferencing tool to do the translation between the hearing users and the deaf and hard of hearing users. And let's say a retail, a deaf and hard of hearing users walking into a retail store, they're trying to find out where the particular item that they're looking for is in which aisle. Say there is a kiosk which has this application, and they're simply able to sign in, and the avatar signs back, guiding the user and also answering some questions. And we talked about the smart home devices where Alexa can provide that sort of like common questions like what's the weather, turn the lights on, and things like that. So therefore, there's many different use cases where these avatars can be helpful. So having talked about the use cases, let's dive into our solution. So what is GenASL? It's a generative AI-powered application that enables individuals who rely on visual communication. So last year, we did the first direction of translating the English audio into ASL avatar video and rendering a 2D sort of a stick avatar. So this year, we have enhanced the capability to generate a human-like avatar and also added the reverse direction where you can pass in and input ASL video and generate the corresponding English audio. So I'm going to dive into the two separate flows in detail. So in the first flow, we have the sign language video generation. So there are 4 different steps involved. And as you can see, this is a decoupled architecture where we have, in the first step, we're converting the English audio into an English text. Now, in the second step, we need to convert that English text into the ASL glass. Rob walked us through what the ASL glass form was earlier. So there is that step that needs to happen prior to generating the ASL video. So once we have the ASL glass in the second step, we convert that into an ASL avatar video in the third step, which is more raw, and it does not have a cohesive frame-to-frame transition. So in the last step, we're adding some capability to smooth that raw video and create a final smooth avatar ASL video. So we talked about the first flow. Now let's look at the video detection on the reverse direction. So there are 2 steps involved in here. In the first step, we pass the ASL video as an input to generate the English text as an output. So there's a lot of advancements in the video understanding space provided by the multimodal models, so using which we are able to do this step. And in the second step, we convert the English text into a corresponding English audio. So we talked about the 2 different flows and the different steps involved in each flows. Let's look at some examples. So a sign language video generation example. So say you pass and upload an audio file into our application. It can generate the English text that's in the first step, and the ASL gloss in the second step, the raw video in the third step, and final smooth video in the last step.
Hello, how are you?
So you can see the hello, how are you got translated, and you can see the avatar that's signing the equivalent version. So now let's look at the example of the reverse video detection example, where you can see Rob signing here, answering the question, I'm fine, thanks, how are you?
I am fine, thanks. How are you?
You can see the avatar that converted that video into an English text and the corresponding audio. So having looked at some examples and the high-level solution, let's look into the multimodal foundational model approach. So what is multimodal AI? So unlike the traditional AI that works typically with just one type of data, so you can think of these foundational models that are like text to text or image to image. So multimodal AI can process and understand multiple types of information simultaneously. So you can think of systems that can analyze images, you can interpret text, and it can also understand speech and even process video all at once. So what's some examples of multimodal models? So Anthropic has Claude 3.5 Sonnet, which provides the multimodal capabilities. And we also have Meta's Llama 3.2 Vision Instruct models. Those are some of the models that are providing the video understanding capabilities. So what are the benefits of the multimodal AI? So it provides a better context understanding and obviously allows us to perform a wider range of tasks, but at the same time comes with the challenges, right, in terms of the data availability, and also it's very compute intensive and expensive. So having an introduction around the multimodal AI, I'm going to walk you through the 2 separate flows and the different models that we've used in each of these steps that I talked about earlier. So in the video generation flow, for the first step, for speech to text, we are using Amazon Transcribe, which is an AI service that provides that capability. And in the second step, we're converting that English text into ASL glass, and we're using Anthropic's Claude 3.5 Sonnet v2 to do that translation. And in the third step, we're using stable diffusion models, image generation models, to generate the video, the raw video from ASL glass. And in the last step, we run that through a SmoothNet machine learning model to generate that final smooth ASL avatar videos. So now let's look into the reverse direction, the video detection flow. So for the first, where from the input video, we're converting into an English text, we are using Meta's Llama 3.2 Vision Instruct 11B. That is a multimodal model, provides video understanding. Suresh will later on cover some of the techniques we have used to provide more accurate results in that step. Now, the second step involves converting the text to speech, and for which we are using Amazon Polly, which is an AI service. So Amazon Bedrock, it's the easiest way to build and scale generative AI applications with the foundational models. It provides a wide range of foundational models to both the first-party models and the third-party models. You can customize your models using your own data and also provide the enterprise-grade security and privacy. So this is to show you all the different models. As of 2 weeks back, the Amazon Bedrock provided models, both the first-party models of Amazon's own model and also the third-party models. And in our solution, we have leveraged Anthropic's model, Meta's model, and Stability AI's models as well. So what are some of the common approaches for customizing a foundational model? So customers typically start with prompt engineering, right? And there's a lot you can do with prompt engineering to steer the responses from the foundational model. And when prompt engineering is not sufficient, there's retrieval augmented generation techniques where you have real-time data that you can retrieve and augment with your queries to still get the responses you desire from the foundational models. When these techniques are not sufficient, customers look at fine-tuning the models, so where it requires changing the model weights and adapting the model to a particular domain or a task based on the data set that you're using to fine-tune. When even fine-tuning is not sufficient, that's when we recommend continued pre-training, which requires training the model from scratch. So in our solution, we've leveraged fine-tuning, which Suresh will be covering as part of the architecture. So, and as you can see, it's in the order of time, cost, quality, and complexity. So depending on the use cases, you would choose the appropriate technique to customize your foundational model. So with that, we're going to show you all a demo. The two separate use cases that I walked earlier, the narrative avatar and conversational avatar. We have 4 scenarios, 2 for each, that Rob's going to walk us through. Over to you, Rob.
Okay, so we're going to go through those 4 different demo videos that Alec was mentioning. The first 2 are more of a narrative situation. So those 2 will show a demo of a scenario that's happening in both of those. And then the second 2 are a demo of a conversational example going back and forth. So Suresh, if you'd like to start with the first one, that would be great.
Hi, my name is Emily
video.
Weber. I'm a machine learning specialist at Amazon Web Services, and today we're going to talk about Amazon SageMaker. Amazon SageMaker is a fully managed machine learning service that developers and data scientists can use to build, train, and deploy machine learning models. Today, we're going to talk about notebook instances, and this is your deep dive. So with the notebook instances on SageMaker, it all starts with a notebook, right?
So now that we've watched that example of the training video, this is something that is near and dear to our hearts, right? Learning from these type of training videos. So we've got these 5 different boxes here. The first one is the video that we just watched, and it's got the transcription there, and then we go to the gloss, then the sign video, then the 2D stick avatar, and then to the cartoonish looking 3D avatar. So at the beginning here, you can see the English, and that's being converted into the ASL gloss that we talked about. It's trying to then detect finding those particular signs to match the words that it's seeing here in English. So you can see that's the Anthropic part that's pulling all of the different sources. We've got files that it's pulling from and putting them all together. That's where the stick figure comes out from the video. That part is very challenging. With the video being, kind of far away, it can be kind of challenging to capture the signs accurately. Also, you see, you know, the video, the woman's in a dark room. Her background is very dark there, so you can see that. The avatar fingers are not matching quite as perfectly, but the model is getting better and better. For example, we've got one story that I can add, actually, if you don't mind, just to share. If you're looking for, like, coming up with images like Stable Diffusion, and I want somebody to sign something, but the fingers, you know, maybe they're counted wrong. Sometimes it would show 3, sometimes it would show 7. So, you know, that was quite challenging to work through that. So enough of my short story. Now we'll move on to the second demo video. The second one here is a live person. So if you imagine something like presenting something live, like here at reInvent. Take it away.
Hello, everyone. Welcome to reInvent 2023. This year, I'm especially excited to stand on this stage and share our vision with all of you. That's because this year, we are standing at the edge of another technological era, an era in which a powerful relationship between humans and technology is unfolding right before us.
So here, pretend, you know, Swami was saying something very revealing and exciting and something that's upcoming in the next few days, right, that we will be witnessing here at reInvent. So this is doing the same thing where it's pulling the voice from Swami's presentation, bringing that in, and then it's going through that process where you see again the English text, and then the ASL gloss, and then the stick figure, and then the 3D avatar. You could put anything you wanted there, but that's essentially showing that process again. It's pretty cool to see that whole process happen. It's going through a lot of steps to get there, and it's amazing how fast it can actually do it too. So now we'll move on to the next part of our demo that I spoke about, those last two, more of a conversational example. So we'll wait for Suresh to bring it up here. So this is a situation in a hotel that you're checking in. I'm sure all of you did yesterday or this morning. So a person who wants to maybe check in here, this is providing the signed content that says good afternoon. And then the staff will say their message. So good evening, welcome to Marriott. You see that here? This is something also where the avatar, especially like was mentioned, you know, the global interpreter shortage as an example, you can pull these things very quickly up with an avatar to have a simple conversation, get it going, instead of, you know, getting interpreters and planning ahead, and you could have this quick and easy available avatar to utilize without a particular schedule. So it's nice to be able to see this interaction going back and forth. Talking about setting up a reservation. The AI chat, you know, many of you probably implemented at some point. It's a similar principle to that, what this process is going through here. So now it's looking for the particular reservation. And then I would ask back saying, you know, thank you. Or if it says something, I can't remember. So yes, it's perfect, thank you. Good signing, it's perfect, right? And then we'll go to the wrapping up of that conversation. Thank you for staying at Marriott. This second one that we have, go ahead and watch here. So that second part of the conversational demo, we can move on to that. Because, you know, in the morning, you need your coffee, right? It was early to get here this morning. Maybe there wasn't anything, you know, available, so you decide, okay, well, I'm gonna go to a big box store and I'm gonna look for the coffee makers. So here it's saying, hey, I need help finding something. That is showing you, a person that's caffeinated and sleep deprived and looking for their coffee desperately. So I say, hey, I need to find where the coffee machines are. So this goes through the same process. The sales associate says, what can I help you find? And then you see this example also of the 1X and 1P that we remember from the gloss before. So you're saying, hey, where can I find the coffee makers? Do you have any on sale? It's an important question, right? We want to make sure we get a good discount. So now the machine is picking up that, where are we finding the coffee makers, from the signed content, and then it's explaining where, navigating where you need to go. So the avatar then could be signing back to this person and say, this is where the coffee makers are, and then I'm gonna like beeline straight to that aisle and get the heck out of there so I can get my coffee. So now, moving on through the process that you watched here, saying thank you. You'll notice some of this. Speaking of that, actually, some of the finger spelling is sometimes slow, or the sign speeds are fast or slow. It's, of course, just a test application, not ready for production yet, but going through these type of scenarios where you have finger spelling that's quite fast coming from the avatar, or the other way around where it can't necessarily detect the particular finger spelling based on the speed. And so also you have the lag of that process and the person who's speaking catching up to it. So, you wouldn't have to, if you slowed it all the way down to a particular speed, then the interpretation of it would get way, way behind. So we are only in the infancy of this, so we're still working through processes like that. And of course, it's the really right place to be at the start of it all, right? So I think we are concluded with the demo portion. So now I'm going to hand it off to Suresh to walk us through the architecture of how he made the magic happen.
Thanks, Rob. As you saw in this demo, this is a test application to showcase what is possible with the recent advancement in multimodal AI and multimodal models. This is not a production-ready application. With that, I'd like to show you the architecture behind this application. I'm going to show the architecture in two pieces. First is the ASL video generation piece. That's going to take English audio as an input and then generate ASL video. And then the second piece is going to, it's a deduction piece, which is going to take ASL video as an input and then generate English audio as an output. Okay, are you ready to get started? Let's see. So I will start with the sign language generation piece. So generating a real-time avatar is going to be time-consuming as well as compute-intensive. So we decided to pre-create ASL avatar and then store that in S3. So for that, we chose Boston University's lexicon video dataset, ASL lexicon video dataset, and then we downloaded that video along with the metadata. So the Boston University dataset is signed by 4 different signers, and then each signer signed around 2,500 ASL signs. So with that data set, we just took one of the signer for this demo application. So the way they distribute that video, one long video consists of multiple signs within that, and then there is a metadata file which says this sign is from frame X to frame Y, and then so we did a prep process to read the metadata and then segment the video file to multiple segments per sign. So there will be one segmented video per sign, and then we stored that in an S3. Okay, now we have the data ready, and now we have to create ASL avatars. So as you saw in that screen before, we are going to create 2 types of avatar. One is a 2D stick avatar, and then the second is like a human-like avatar. For the let's see how we can create a 2D stick avatar. For that, we used 2D post-estimation algorithm that we used last year. That's a post-estimation algorithm called RTM post. We use that algorithm through post framework. So what is 2D post-estimation algorithm? So basically, you can give an image of a human, and then that 2D post-estimation scans that image and then come up with 133 key points, like mostly the joint location, where eyebrow is, where the lips is, and other stuff. So we take the 133 key points and then plot that on a blank image that will create the 2D stick avatar. And then we have to repeat that same process for every image, because like most of the signs will have 30 frames. So we need to repeat that for 30 frames to create a 2D stick avatar. And then we store that resultant video in S3 bucket, and then create a database entry with the S3 key and then the ASL sign associated with that. Now let's move on how we can create the human-like ASL avatar. Initially, we started with looking at 3D mesh post-estimation algorithms, but the results were not great and it's not useful. So we moved on to using image generation foundation models like Stable Diffusion. So one of the challenge with that is, this image generation foundation model creates different type of images for the same input. So we need to control how the image is getting generated. So for that, there is something called control net. Control net is a neural net based foundation model that kind of guides the image generation foundation model to generate image in a certain way. So for the control net plus Stable Diffusion, we give a prompt. So prompt might be like a create a sign or ASL avatar, and then the video will be the source Boston University sign video. So from those two inputs, the Stable Diffusion creates the human-like ASL avatar. And like Rob pointed out, like the avatar is still evolving. Especially with the Stable Diffusion, there are some fingers missing. So we had to apply a finger correction layer to fix those. As well as like this example is using Stable Diffusion 1.5, and then switching to the recent version of Stable Diffusion or other foundation model, the human-like avatar generation can be improved. Okay. So now we have our data set ready with both 2D avatar and then the human-like avatar. Now let's look at the front-end architecture. The front-end is developed using AWS Amplify Gen 2. AWS Amplify allows developers to develop, build, deploy, and host full-stack applications easily. So for this demo application, we used React with TypeScript, and then also we used Cognito for authentication and authorization, and then we were storing all the video files and audio files coming from user in an S3 bucket using Amplify's storage APIs. Okay, now we looked at the data prep process and then the front end. Now we can see how we can glue them together and then generate the ASL avatar in real time. Okay, for this, we created a generation API. The generation API is exposed via API gateway as a request response method interface. And then the API gateway is going to accept either an audio or a text as an input, and then it's going to delegate the call to a step function. A step function is going to perform the 4 steps outlined by Alak before. The first step, if the incoming request is an audio, it's going to take the audio and then convert that to an English text using Amazon Transcribe. Here, the step function has a direct integration, enhanced integration with Amazon Transcribe, so you don't need a Lambda function here. So it will does the call. And then the second, we are going to take the text and then convert that into ASL gloss. For that, we are using Claude 3.5 Sonnet V2. So with the prompt, it's going to convert that to a ASL gloss and then return the response. Here also, step function has a direct integrations with Bedrock, so you don't need a Lambda. And the third step, we are going to take each gloss and then look up the database and then download the corresponding 2D avatar video and human-like avatar video, and then keep that. And then the fourth step is a new one you introduced this time. It's going to, when it's concatenate those videos, it's going to apply a SmoothNet model that will smoothen the video, and then the smoothened video will be stored in an S3, and then a pre-signed URL is created, and the pre-signed URL is sent back to the front end. The smoothing is needed because hello will be like this, and then U is going to come like this. So there will be a sudden drop in the hand movement. So we need to use SmoothNet model to smoothen the video stitching. So that concludes the sign language generation part. Let's move on to the sign language detection. Sign language detection, this front-end application accepts two types of input. One, you can upload a pre-recorded video, so that pre-recorded video will be uploaded to S3, and then the S3 key will be sent to this detection API. And then the second type of input is a camera feed, the real-time camera feed, that will go to Kinesis video stream, and then the stream name is sent as an input to this API. Now let's look at the detection API. The detection API is also exposed via API gateway, but this time it's through WebSocket interface. The reason is it's going to send a request with either the S3 key name or a bucket name or a stream name, and then the backend is going to process it and then start requesting response. So we need a stable connection. We need a persistent connection between the consumer and then the backend Lambda applications. So that is provided by the API gateway. And then here, when you take the video segment, it's going to take every 5th frame and then create an animated image, and then the animated image will be sent to a fine-tuned Llama 3.2 11B Vision Instruct model, and then the Vision Instruct model is going to respond back with the English text. And then the English text will be sent to Poly to convert that to English audio, and then the audio is sent back to the front-end application. So I mentioned about fine-tuning Llama 3.2 11 billion Vision Instruct model. I'll just start with sharing journey about why we came to that conclusion. First, we started with using LSTM model, long short-term memory model, with all the 133 key points from the data set, but the results were not good. So then we moved on to using deep learning model like YOLA V9, and then that results also not that great. So we moved on to transformer-based models like CogVLM, and then that's also not that great. So then we started using Claude 3.5 Sonnet V2 and Llama 3.2 Vision Instruct models. But since those models were not trained on ASL data, the results were not great. So we decided to fine-tune that Llama 3.2 11 billion Vision Instruct model. The way we did it, we took the Boston University ASL LVD as an input, and then kicked off a SageMaker Jumpstart training job. The training job is going to fine-tune the Llama 3.2 model, and the resultant artifacts will be stored in a S3 bucket. And then we used Bedrock's custom model import feature to import that updated weights into Bedrock, and then use the Bedrock Converse API to inference against the video for video detection. So we send a video to the custom imported model, and then that sends the English text back. Okay. So here, just putting the both generation and detection flow in a end-to-end architecture. So we already covered this one, and then let me move on to the next. So how this can help you? Like as you looked at both how we build this generative AI application, I'd like to share some of the best practices you can use when you build your applications. So the first use case is a live streaming GenASL API. So one of the demo where we are doing the reInvent keynote, and then we are live streaming that, and then we can use this API to create ASL avatar. For that, assume that live streaming is going through Elemental Media Live, and then we need some kind of compute, and then we have the we call the GenASL API from that compute, and then the ASL API is going to return the video back, and then the video will be broadcasted back through Elemental Media Live, and then it will be packaged by Media Package and distributed via CloudFront. But we need the compute here. The compute is going to do two things. One, when we say simple text like hello, how are you, the audio length might be 1 second, but the resultant video length might be 3 seconds. So in that case, you need to speed up the resultant video so that audio and then the ASL video are in sync. Also, sometimes you may want to slow down if it's like a pass on the audio input. So you need to do that. Also, you need to slow down, or you need to delay the original broadcast by some couple of seconds so that the ASL video generation is compensated. So those are considered like, if you are planning to integrate this API into live streaming, consider those two best practices. And then why Amplify? We used Amplify Gen 2. Amplify Gen 2 allows you to use any of the AWS services as a custom CDK component. And then also we used Q Developer. I would say 70% of the code for this application is auto-created by Q Developer. Then we need to fix it and test it. But we need to come up with the prompt for the Q Developer. And then the other thing about the Amplify Gen 2, especially Generation 2, you can export this entire application as a CDK component, and you can use that in your existing CI/CD pipeline. So Amplify Gen 2 comes with its own CI/CD pipeline, but in Generation 2, you have the flexibility to use your own CI/CD pipeline. And then Amplify also gives higher level APIs for storage, authentication, and then GraphQL, and then also it allows hosting. So the higher level API is especially useful for a kind of a low code solution. You can use a S3 bucket with just a couple of lines of code. Same thing with authentications. And we also used API gateway in both detection and then generation API. And then especially in the detection API, we use WebSocket, secured WebSocket, WSS. And then that provides connections between consumer and then the backend Lambda function. So the Lambda function can send a response back to the front-end application every 2 seconds with the text is identified. So the API gateway supports both request response and WebSocket APIs. And then also we enabled API endpoint caching. That's really helpful to reduce the workload, reduce the load going to your backend API implementation. Also, it improves the performance of the API also. Some of the features we use from the Bedrock, I'll touch on those 4. One is the Converse API. So especially any GenAI application, you are going to evaluate your use case against multiple foundation models. So this Converse API provides one unified interface. So you can write your prompt and then the inference parameter against Converse API. Converse API will directly translate that to the message format required by the foundation models and then the inference needed by the foundation model. So when you are testing against multiple foundation model, all you need to do is change the model ID, and then you don't need to change any of the other parameters like inference parameters or the message format and etc. So the Converse API is really helpful for model evaluation and then identifying a proper model for your use case. And then the second is, like as you know, the prompt, like we play with the prompt, come up with the best prompt for your use case. So we'll change the prompt. Prompt management allows you to create and maintain and then version history and then use prompts with efficiently. So at some point you may say, okay, what is the prompt I used like 5 versions ago, and then you may miss it. So also it allows you to externalize the prompt into Bedrock prompt management, and then you can change the prompt ID and then rerun your code to test against multiple prompts. Also, since all the foundation model requests are very compute intensive, there are throttling limits at each level. So by enabling cross-region inference, we are able to mitigate some of the cross-region throttling errors. And then fourth one is the must-have. When we have this text to convert English text to ASL gloss, that's very easy for a prompt injection attack. So enabling guardrails to mitigate the prompt injection attack and then filtering some harmful content is a must-have. Those are some things to consider when you build your own GenAI applications. So what's next? I just shared you, our journey in building these applications, and then the lessons learned along the way, and then some of the best practices you can follow when you build your GenAI applications. So we also plan to add like multilingual support to cater broader audience than just ASL users. So that can be easily added by ingesting other sign language data set into this framework and then support it. And then, as you saw in our solution, our architecture is a decoupled architecture. It's putting together multiple foundation model and then orchestrating it carefully to come up with the solution. But the way the current generative AI landscape is moving towards artificial general intelligence with advanced LLM agent capabilities and then unified multimodal models. So let's say you have one unified multimodal model that can take English audio as an input and then generate ASL video, and then take ASL video as an input and then generate English audio output. That will be ideal. Because that will improve the accuracy of this translation because it knows the context around it. Also, it improves the video and audio quality, and then the quality of the video will be improved if you have one unified multimodal model. With that, let's kind of conclude. So if you want to learn more about our solutions, we published our last year's solution in AWS ML blog. That blog also has a link to the previous year's source code. Feel free to have a look at it. And then if you want to learn even more, we have a Chalk Talk session titled Accessible Live Streaming Using Generative AI for Inclusivity today from 12 to 1. Where we'll be whiteboarding this architecture and then answer your questions, and then hope to see you there. And then with that, thank you all for coming to our session. Please take a moment to fill session survey in your mobile app. Your feedback is critical to us, so we appreciate it. And then thank you.
Yeah. Thank you so much.